Hello, this video is for Stat 110, Module 3, Part 2, and includes a discussion of the substance abuse case study. What's different about this case study compared to the one considered in Module 3, Part 1 is that the expected counts are no longer going to be the same across the categories. This results in a modification that will need to be made to the test statistic that we were calculating previously. Okay, let's go ahead then and get started with this handout. So as I mentioned, Module 3, Part 2 includes a discussion where the proportions are not equal to one another, and that results in the expected quantities to not all be the same. The case study that we're going to consider here is from the Minnesota Student Survey. We're going to look at outcomes regarding substance abuse. The Minnesota Student Survey is an important vehicle for the youth voice in Minnesota. Many different governmental organizations across Minnesota use the information from this survey. The source is provided here, and you can actually create custom reports for your particular school district if you went to a school in Minnesota, or you can get that information by county or by city, etc. So that website allows you to create custom reports. And that's actually what I did to create the information that I have here. There's a bunch of information here on the screen. These are all regarding the perceived risk from substance abuse, So we have information about perceived risk on smoking. The students could select from their survey no risk, slight risk, moderate risk, or great risk for each of these categories. I have information then from the grade 5, grade 8, and also grade 11. That information has been broken down for females and males as well. What I'm going to consider in this handout is how much do you think people risk harming themselves physically or in other ways if they have 5 or more drinks of alcohol beverage one or twice per week. Okay, so the investigation that I'm going to be looking at here is around alcoholic beverages. Again, the students can respond with no risk, slight risk, moderate risk, great risk. And I'm going to be looking at grade 11 students. I'm going to combine the information from females and males together to just get a single value for no risk. Just 20 of them, it looks like. A single value for slight risk, which was 31. Moderate risk, which is 35. And great risk, which is 39. So the data that we're going to be analyzing here is the 20, 31, 35, and 39. We are going to be comparing these outcomes against historical trends for grade 11 students. The data that I've collected here is for Fillmore County. Fillmore County is down in this corner of Minnesota. That's actually where I live, is in Fillmore County. So again, here's a breakdown of the data, 20, 31, 35, 39. Here's just a simple segmented bar graph that shows each of those values. I'm going to be comparing Fillmore County information against the historical rates for the state of Minnesota. So for grade 11 students, the historical patterns are as follows. Only about 8 out of every 100 believe that there's no risk when one consumes alcoholic beverages once or twice per week. The slight risk is 22 out of 100, or 22%. Moderate risk is 30 out of 100, and the great risk is 40 out of 100. Again, this information is for grade 11 students. So I'm going to be comparing these observed numbers to these historical percentages. So the research question here, is there evidence to suggest that grade 11 students from Fillmore County deviate from these historical patterns? And these historical patterns are coming from other grade 11 students throughout the state of Minnesota. There's the H0 and HA statement. Again, the H0 is set up under a there's no difference situation, and HA is going to be set up under they do differ. We once again are going to have 4 parameters here, one for each of the categories. These proportions are as stated here. Pi sub no, or the parameter for the first group, is going to be equal to 8%. Again, this is coming from the historical percentages. For the slight risk, it's 22%. The moderate risk, it's 30%. And the great risk, it's 40%. So I'm trying to evaluate whether or not the Fillmore County tends to deviate from these historical patterns. If they do not deviate from these historical patterns, then this should be the breakdown. The 8%, 22, 30, and 40%. So I'm going to use those proportions or percentages when computing my expected numbers. So here on the screen, we have the observed counts, the 20, 31, 35, 39. There's a total there of 125 students that were surveyed in grade 11 from Fillmore County. How many of those 25 should believe that it's no risk? Well, I would just take the 125 times 0.08. If they are following, so if Fillmore County is following the historical trends, I should see about 10 students selecting no risk. We actually saw 20. There's quite a bit more that believe that drinking once or twice per week is of no risk than in Fillmore County, than compared to the historical trends. For the slight risk, we should see about 27 or 28. Again, taking the total of 125 and multiplying it by the proportion that is provided in the null hypothesis, or the proportion from the historical percentages, which here was 22%. Likewise for the moderate risk and great risk. So now I have a set of observed counts, 20, 31, 35, 39, and I have a set of expected counts, the 10, 27.5, 37.5, and 50. And we're going to do the same thing that we did before. We're going to compute that distance from the observed to the expected across all 4 categories. I'm going to need to square those distances. So that's what we're going to do next. Getting the simulation model is much the same as what we did previously, except the proportions are not the same in my hat. The proportions now are 8%, 22%, 30%, and 40%. I'm still going to get lots and lots of repeated iterations, each time picking out 125. Here I've done 100 repeated simulations and plotted those on the screen. One thing that we notice is that the location of the pyramids are shifting. They're not all the same anymore. The first pyramid is 8% of the way up the number line. The second pyramid is 22% of the way up the number line, and then 30% and 40%. Again, those proportions are coming from those historical rates here. We're going to look at each of those individually. Okay, so if we did that, applying the 5% rule, you can see that I'm an outlier here for the no risk, but not an outlier in any of the other categories. As I said, we got to take this information and condense it down into a single number like we did before. That's what this table is showing here on the screen. I'm taking the 20 minus the 10, and then I need to square that. I get a value of 100. I need to do that for the slight risk, and I need to do that for the moderate risk. I also need to do that for the great risk as well. So I would take 39 minus 50, end up with negative 11. I square that. I get 121. If we look at these values for a moment, we can see that 2 of these categories are quite far away from what I would expect. So the outcome for no risk and the outcome for great risk are far away from what I expect. And I know that because the distance values are quite high. And in fact, the largest distance value after I take the difference and square them is from the great risk category. The great risk group, we were 11 off from what I expected. So if we look at this in the pyramids that I have, 39 was my observed for the great risk category. I expected 50. I was 11 off from what I expected. Up here in the no risk category, I should have seen 10, and I was 10 off here. One thing that we'll notice here in looking at this graph is that being 10 off is actually an outlier in this picture. I'm beyond any of the dots here. So what that tells me is that being 10 off is quite a bit when the expected value is 10. Down here, being 11 away is not an outlier. So even though I'm further away from what I expect, I'm not that much of an outlier. I'm not more extreme than what I saw up here. And the reason that is occurring is because, as I said a moment ago, being 10 off when my expected is at 10 is quite a bit. That's a lot. But being 10 off when my values are around 50, that's not as much. Or even being 11 off when my values are around 50, that's not as much. So the inherent variation in this reference distribution is higher for great risk. I need to reach out further to get to the edge of the distribution than I do in this distribution. This distribution is pretty closely, it's pretty tight. It does not have a lot of inherent variation. That's because the expected count is so low. So we need to worry about this fact when we're computing this total distance. We can also see that here, being 10 off is definitely an outlier in the no risk group, but being 11 off is not an outlier for the great risk group. So when I'm computing that total distance, or that distance squared, I need to worry about where that value is located, about where that reference distribution is located. I need to put that distance squared into perspective a little bit. And how we do that is by just taking that distance squared and dividing by the expected. So let's look at the formula here. So again, the problem that we were confronted there was that the current measure of extremeness, just using distance squared, does not take into consideration the relative position of the reference distribution. So a difference of 10 is a lot when the expected value is small, but a difference of 10 is not going to be a lot if that expected value is much larger. What I said a moment ago is we just take that distance and we divide it by the expected. What that allows us to do is it does take the relative position of the reference distribution into consideration. Now, just a quick comment. Understanding the relative position of a measurement is not unique to the situation that we have here. For example, if I said I was going to give someone a $2 per hour raise, is that a lot for that individual? And that certainly depends on what their existing hourly rate is. If they're making $10 an hour, then a $2 an hour raise is quite a bit. But if I'm talking about a lawyer who is making $275 an hour, then a $2 raise is inconsequential. So again, you need to worry about, if I'm giving somebody a $2 an hour raise, we need to understand where their perspective is from. And that's the same thing, or the same issue that we have when computing this test statistic. And to alleviate that, we're going to divide that distance squared, divide by expected. And if you look up Pearson's chi-square test on Wiki, you can see that this is the formula that they give. The O is the observed values, the E's are the expected. I look at how far apart they are, I square that, because I need to worry about the canceling out effect that we talked about previously. And then I need to take that distance and divide it by the expected to put that distance in perspective. And then this summation sign in front just means add those up for all of your categories. Okay, so now we're ready to get our test statistic for our example. And all we're going to do is take those distance quantities and just divide them by the expected. So here I'm going to take the 100 that I had before and divide by the expected of 10. Turns out that that value is 10 itself. I'm going to take 12.25 and divide by its expected. The slight risk, the expected, was 27.5. I'm going to take for my moderate risk the distance squared, which is 6.25, and divide by its expected, which is 37.5. And then I'm going to take that 121, which was the distance squared for great risk, and divide that by 50. And you can see that we are dampening that quantity quite a bit now. It's 2.42. So now the biggest distance from expected using this adjustment is actually from the first category, the no-risk group. And it should be. When we were looking at whether or not they were outliers, the no-risk group was the one that was an outlier. This group here is pretty much close to the expected. So that distance squared divided by expected is going to be small for this group. It's going to be fairly small for this group. And it's also going to be dampened down because I'm dividing by 50 here for this group. We call these individual values here the cell contributions. So the 10, the 0.45, the 0.167, and the 2.42 are called the cell contribution values for the test statistic. I'm going to take all of those quantities and add them up again, just like we did before, and I'm going to end up with a value of 13.03. Now my task is to determine whether or not 13.03 is an outlier. I'm going to do that just like we did before. So this is analogous to what we did before, except I'm using the expected in the denominator each time. Here's the spreadsheet table. Again, I'm going to make a plot of the total distance values over here on the right side. Here's a plot of what that looks like for 250 repeated iterations this time. I'm just going to count the number of dots that exceed that 13.03. Again, the 13.03 is the value that I got from our data. So I need to take these observed counts, do some processing of all of that information. Again, subtracting off the expected, squaring, divide by the expected, and add them all up. So my observed value is 13.03. That's the value that came from the data here. And I need to determine whether or not my data is extreme. So I need to determine whether or not 13.03 is extreme in this picture. I count the number of dots that exceed that, and I only have one out of the 250 dots on the screen. So my p-value here is going to be 1 divided by 250, which gives me a value of 0.004. Once I have that p-value, I'm able to answer my research question. So the rest of this is just like we've been doing all along. Is there evidence to suggest grade 11 students from Fillmore County deviate from the historical patterns of other students in grade 11 throughout the state of Minnesota? My p-value is 0.004. That is less than 0.05. I have enough evidence for the research question, so I can write my conclusion like we have been here. Okay, some comments then. The research question posed here asked whether or not the proportions from Fillmore County deviated from the trends from the rest of the state of Minnesota. This test, as we've talked about, is a two-sided test. However, a one-sided test may be more informative. For example, if the researcher asked, do the grade 11 students from Fillmore County have a more laxed perception regarding substance abuse of alcohol? Unfortunately, a one-sided test cannot be done. Statisticians do not have a one-sided version of a chi-square test. We can use a spreadsheet to do these calculations as well, and that's going to be done in the next part. So in a spreadsheet, all I need to do is just obtain the observed counts, and then compute the expected counts, which here are the 10, 27.5, 37.5, and 50. And then I can just use the chi-test function to compute the p-value. The spreadsheet is actually going to use the theoretical approach to doing the chi-square test. Again, the theoretical approach would be, what would this picture look like if I did an infinite number of dots? So the spreadsheets are going to base their reference distributions off of theoretical reference distributions, or in particular, what's called the chi-square distribution. So if I let the number of dots obtained in my reference distribution go off to infinity, we end up obtaining something called the chi-square distribution. Here's another example. We're going to do alcohol abuse for grade 11 students from Winona County, not Fillmore County. We're still going to use the 8, 22, 30, and 40 as the proportions because, again, these are still grade 11 students, but just from a different county here. Here's what the data looked like from the customized report that I ran. The no risk was at 7, slight risk 26, moderate risk 30, and great risk 48. There were 111 total students in Winona County that were surveyed for this question. I want you to go ahead and answer these questions here at the bottom of this page. Okay, so go ahead and just do the calculations that I asked. There's a missing calculation here that you're going to have to figure out. You're going to have to get the sum here, and then just try to answer these questions that are provided. Okay, that does it then for this handout. And this handout was Module 3, Part 2, a discussion of the substance abuse case study. Okay, thank you.